Okay, hi everybody. Problem 17, prove that this sequence converges. Okay, so we're going to use the convergence game. And first I'll just sort of say what's you're thinking, or maybe you could call it scratch work, like the book calls it scratch work. Okay, so in my head, I think that 0.8 plus 0.5i is somewhere inside the unit circle. So call C equal to 0.8 plus 0.5i. Then C is in the unit circle. Okay, then C to the n should basically go to 0. Okay, now if C to the n goes to 0, as n goes to infinity, then this thing should go to this number, because this will go away, go to 0, and then this will be remaining. Okay, so my guess is that let's call Zn this expression, the thing that we're taking the limit of. And now claim, or we think, that Zn goes to 3 plus 2i. Okay, well then what do we need to do? For all d, there exists some capital N such that going past that point implies we are in the ball around this number. Let's call that number called W equal 3 plus 2i. Okay? Now, this is all still just scratch work, because I have no idea how to explain this later. Because remember, the whole point is to explain, really, to carefully explain the logic. That's what I need to do eventually. So right now I'm just doing like pre-work, work before I can begin to actually write my answer. Okay, so it makes sense to examine this. Now we're going to sort of calculate. Well, we need to show that this thing is less than d. That's what we would like to show. And we're going to just calculate in order to hopefully find out, like, what should n be. Calculate to find out what is capital N. Okay, so first of all, just replace this and this by their full formulas, which means I need to really do a lot here. So what is z to the n? It's all this, and then w is just this. So actually when I subtract them, when I do zn minus w, this piece from zn will cancel with w, and it'll just leave me 0.8 plus 0.5 to the n. Oh wait, but I made a name for that. I was going to call it C. And actually, this is too much detail. And you'll sort of learn to get a feel for this, like, when should you hide the detail? Well, in this moment, you should hide the detail. Okay, so actually I didn't need all that space. Wow, see, this is why it's scratch work. This whole expression became this. And so I might as well just say, well, okay, this inequality, I don't know if it's true or not. But if it's true or false, it'll be true or false if and only if this inequality is true or false. So this is true if and only if this is true. Why? Because all I did was just replace these by their definitions and observe that this and this canceled, and then call that C. So I just sort of renamed things. I did do a subtraction. Yeah, okay. Now this inequality is true if and only if the absolute value of C to the n is less than d. So all I did is I pulled this outside, which you can do because of how complex numbers multiply. When you multiply a complex number by itself, like remember z and w, this was equal to the norm of z times the norm of w. So c squared is c times c, which is equal to the norm of c times the norm of c, which is equal to the norm of c squared. So that's why I can pull out a 2 from there to there. So that explains this step. I can keep this around. This was me explaining sort of this step here, this if and only if. Okay, so now this absolute value of c is a positive real number, and it's less than 1. That is going to be important because that was where our whole intuition came from, that we made us guess that this c to n would go to 0, is because it was inside the unit disk. Okay, so it's this is a positive real number less than 1. Okay, so that's sort of in my head. I'm thinking that, and it's actually a true statement that I can use later. So then now I have this inequality, and I'll say that inequality is true if and only if the natural log of both sides. So here I took log of both sides. That explains this if and only if. The if and only if that says this thing is true, if and only if this thing is true. Okay, and then properties of logarithms, that's the whole reason to take the log, is that we can pull this n down. Okay, now here's the second crucial part. This inequality will reverse. Why will it reverse? Divide by a negative number. What am I doing? This is a negative number. Why? Because the absolute value of c is less than 1, is a real number that has absolute value less than 1. So when I divide both sides, this expression is negative because, remember, we can take the natural log of any positive number. Like the absolute value of c. And if we look at the graph of log, right at this point, at 1, it is 0. And then anything less than 1 at any of these points over here, you get a negative number, Okay? So that's why we're dividing by a negative number, because this was negative. And now we're good. Now we see if we choose n greater than ln of d, ln of c, then if n is greater than or equal to n greater than or equal to n, which is greater than this, and now we have, just look here and here, we have that n is greater than ln d, ln c. And by this chain of if and only if logical implications, if we have this, it is equivalent to having this, which is equivalent to having this inequality, which is equivalent to having this inequality, which is equivalent to having this inequality, which is equivalent to having the inequality that we wanted. And now I have finally done thinking. Okay? So, now I'm ready to begin my proof. Carefully explain the logic. So let z sub n equal 3 plus 2i plus 0.8 plus 0.5i to the n. Claim z sub n converges to 3 plus 2i. And so let's call this w, and let's call this c. okay? I might want to say this in sentences, but if you just leave it like this is clear enough. It's not too crowded, but you're kind of pushing it already if you're sort of doing these shortcuts. Alternatively, you could just say let, w equals 3 plus 2i, and c equals 0.8 plus 0.5i. Okay? That is much nicer. Now we can help our reader. Because remember, what do I actually care about? Do I care that you did this? No, I don't care about this at all. What I care is that to know, can you carefully explain the logic? Because that is the point of this, is to convince your reader of the truth of some statement. Okay? You already believe it's true. You've done this. You believe it's true. Now you need to convince the reader. Okay, so what do? Need to show, like, what does it even mean? How do you prove this? How to prove this statement? Well, need to show, tell the reader the definition. For all d, there exists a capital N, such that when little n is past that point, we are less than d. That is just the definition. I am telling the reader what this means. Okay, and now I should say, well, what is d? Is it an elephant? No. What's this? Well, it's an index. It's a natural number. For all d, there exists an n. Okay. Now I have to think a little bit. How do I carefully explain to my reader what happens next? So, let d be given. Then choose capital N greater than the natural logarithm of d divided by the natural logarithm of the absolute value of c. And so your reader's like, what? Okay, I can do that. But they have no idea why. And you're going to tell them in a moment. So you can do this. This is some number. D was given to you, so the natural log of d is some number. C is a fixed complex number. Here it is. You told the reader what it was. So you can take its norm, and you can take the natural logarithm of that positive number, and you get this number. So just choose some capital N bigger than that. We can do that for any d. This formula tells us how to choose. Then, n greater or equal to capital N implies that n is greater than ln d, ln c, right? Because we chose capital N bigger than that. Okay. So far, so good. Now we apply the calculations, okay? So what do? By the chain of if and only if inequalities in star, and now I'm going to refer to a box where I'm going to put all my calculations very nicely, we then have that Zn minus W is less than D as needed. End of proof. Well, not end of proof. I need to actually give star. So where's star? So star is maybe down here. And I'm going to very carefully repeat this chain of arguments, but very nicely. So Zn minus W less than D if and only if C to the N less than D, if and only if the absolute value of C to the N less than D, if and only if the natural logarithm of these things, both sides, if and only if N times the natural log of the absolute value of C, and I just don't do anything to the other side, if and only if, and here's the key, this less than flipped. And that's star. And that completes the proof. Okay? So you see how I carefully explain the logic behind this proof. I set it up, I say, let this be that number. So I'm defining, I'm claiming this claim. And then I maybe make some more definitions that will be helpful to hide details. So this will allow me to hide details. And then I remind the reader, like, what am I trying to prove? What does it mean to prove that? It means this. Now, so this is all set up. This part is set up. And now here's the actual proof. And here's the calculation. So this is actually probably pretty generally true. You first put the setup, then you actually do the proof, which at some point will refer to some calculations. I actually like to sort of separate them out. Our book actually doesn't separate them so much, but I like this kind of 3-part proof. It has a setup and a calculation and then the actual proof. Okay. All right, so to be clear, this will be on your paper somewhere, but I am not going to read it. It should be scratch work. In fact, I'll give you plenty of blank sheet of paper to do this. And then this is what I read. I'm your reader, and you need to convince me with something like this.